Okay, so today we're going through intro to the FRC control system. So this will be what the actual hardware, the electrical, the main robot controller, all of that stuff, and we'll have a basic introduction to it so we know kind of what we're going to program when we start doing that shortly. Okay, what we consider the FRC control system, what it does is it powers the robot. So that's how it has electrical power that it uses to be able to move around the field, move all of its subsystems, its launchers, its elevator, all of that. It controls the motors on the robot, so it can tell them how fast to spin, what direction. The control system communicates with the driver station, so it's how the drivers are able to operate it using their game pads or joysticks. And the control system also collects and uses information it gets from sensors, which is how the robot kind of knows about its environment. So it can detect different objects and it can do different things with sensors. We'll expand on all of those things here shortly. Okay, so this is a portion of the FRC control system in graphical form. So there are just kind of a brief overview. So there's the main battery, which is what powers the whole robot. That's where we get power from. So we'll put a new freshly charged battery in every match. It connects with a special battery connector. It's called an Anderson. It's like this red battery connector. Basically, every team uses pretty much the same one. There's a couple teams who use something different, like the rules allow for a couple different things, but largely everyone uses the same one. And then we have really thick, big wires because this has all the power running for the entire robot running through it. So it has the largest wires on the robot go from the battery, and then they go through what we call the main breaker, which is basically the on and off switch for the robot. And they go through and then to this device right here, which is the power distribution panel, which is how everything on the robot gets all of the power it needs. So it's how we connect all of the motors and any devices on the robot. Anything that's getting power is always getting it from the power distribution panel. Over here we have the Roborio. So this is the main controller, like the computer for the robot. We're going to talk more about this in a second. And we have the radio, which is how it communicates back to the driver station. And it does it over Wi-Fi, basically. So just like your computer connects to the internet, the robot is able to connect to the driver station, and we can transfer those commands, any like the joystick buttons and all of that, wirelessly to it so we can drive it around the field. We'll talk about more of like how the wires are in each of these things as we go through. Okay, so the battery, like we said, is the main source of power. It's a 12-volt battery, so it's the same. You basically consider it like the same voltage as the battery in your car. Our batteries are a lot smaller than a car battery. They're designed a little bit differently, but they have like that same type of ideas. Like all like the electronics in your car are able to be powered, and all those work. Our robot works in a similar way. The battery is heavy. It weighs about 14 pounds. So one of the reasons to know about the battery weight is it has to be somewhere on the robot. So that can often change. Like if you mounted it really high, it might make the robot tip over. If you mount it to the front will be heavier. If you mount it to the back will be heavier. So you have to think about where the battery is going to be mounted on your robot because it's so heavy. We already talked about the connector. The main breaker, we'll talk about this multiple times, but basically the main breaker, this red button right here, and we'll have a picture of the real one shortly, is the off switch. So that's really important. So if the robot's doing something and it's not supposed to, or if you just see a robot on and it's not supposed to be on, pushing the off button is very useful. So you can find this on all of our robots. They turn off the same way, and you push the red button in to turn it off. This image doesn't show it very well, but there's a little black lever kind of down here next to it that you have to like kind of flip in, and that's how you turn it on. So off is really easy, nice big red button. On takes a little bit more action, kind of intentionally, so that the robot doesn't accidentally get turned on in any way. You can't just like you can't just like knock into it or something and turn the robot on. So it makes it a little bit safer. And then the PDP splits power out to everything. Okay, so batteries again, these are what the batteries look like in real life. They'll have already have connectors and wires on them when you see them, but it's one of the things that we have to do is we have to put connectors on them for our robot, and that's actually a really important step that a lot of teams don't necessarily get right. If how you put those connectors on can make sure that you don't have like a loose connector, because then if you have something that's able to wiggle loose, that's all the power for your entire robot. So if this connector gets loose, your robot just stops working for part of the match, and you never want that. We charge them every time we use them, so they'll go bad if you don't. So if you drain a battery and use it if you use it for a long time or for a whole match, and then you just leave it somewhere, leave it on a table, and you don't charge it, the battery will go bad. It not necessarily won't be able to be used because we can still use it for certain things, but you wouldn't want to use it for a match battery. Basically, it won't give you as much power as you need to be able to do everything we do in a full competition match. One of the biggest things to know is that you never drop the batteries. One, they're heavy, so if you drop the 14-pound thing on your foot, it hurts, so don't do that. So for your safety. But two, once you drop it, it's very likely damaged on the inside, and then that one we really just can't use at all because it's just not going to work well. It'll work for maybe a little bit, then it'll just stop working. You also always hold the battery when you're carrying it. You hold it by the actual battery itself, never by the wires coming out of it. In general, don't hold anything by the wires if you can, right? Especially heavy things. The wires aren't designed to hold the weight, so you can like rip out the connectors from here and you can just like rip them straight out of the battery, or you can damage them on the inside and make them worse. Always hold it by the actual battery itself, never by the wires. Okay, so the battery cable, and these are the wires that are connected to it, the battery wires, are, like we said, they're the really thick wires. So they're normally red and black. A few of our batteries have a white and black, and we talk about wire polarity a little bit. But something, basically one of those two color options pretty much always. You almost always have a black wire, and then you'll have a red or a white wire. This large red connector down here is the battery connector. Like I said, it's standardized, so any of our batteries will plug into any of our robots, making it nice and easy. It's called the Anderson connector, and it lets us easily unplug and plug back in batteries, swap them in and out. We don't have to like unscrew or unbolt anything. For actual competition matches, we have like a strap that'll go across the two connectors and make sure it's held in, because if for some reason they were able to pull out during a match, same thing as if the battery cable got loose, your robot would stop running, and we don't want that. Wire polarity. So this is what I was just talking about with the colors. So on our robot, and on most robots, red and white are your positive, black is your negative. The manual has a full list of exactly what colors you can use in different places. These are by far the most common. So whenever we're talking about like the positive side or something, it's almost always the red or the white side, and the negative is always the black side. This is not the same if you like open up the walls in your house to like change a light bulb or a socket or something. Those aren't the same things because it's like house wiring and car wiring or robot wiring are two very different things. So don't like take anything you learn here and try to like use it at your house. This is just for robots. It also normally it works for cars too. Red and black is going to be the same in most cars. So whenever we need to control something, or if you need to connect something, every time on our robots, you always connect like a red wire to another red wire or a red wire to a white wire because they're the same, and then black to black. If you ever see something that is backwards where you have like a red wire connected to a black wire, you should probably ask me, ask someone who's, if they're doing something that if it's intentional, right? A lot of times some people maybe make a mistake, they'll plug something in backwards. But rarely do we ever do that on our robots. There are a couple other wire colors that happen on the motor controllers, which we'll talk about what those are later. But basically, they'll often have a green and white wire instead, and so then the black connects to the green, and the white or red will connect to the white wire. Okay. Sorry, slideshow did weird things. Okay. Main breaker again, we already covered most of this. again, this is the red button on the real, like what the real device looks like, not just the picture. So when you push this in, it turns off. When there's this little black lever right here, you can kind of see it, and that is what has to be in. So right now this is on. Since this lever is in and like kind of in line, it's on. When you push the red button, this thing will pop out and it'll be like drawn down there. So it would actually be, the little black lever would be down like this. And so if that's out, then the robot's off. And then when you push it back into this little spot, then it turns on. The reason it's called a main breaker is there is a way for it to turn off automatically. So if the robot is doing something where it's basically trying to get too much power out of the battery too quickly, and it's basically trying to protect the robot from causing a fire. So it will turn off by itself. If you try to get too much power out of the battery way too fast, it'll turn off. So if you do that during a match, your robot's off for the rest of the match. So you don't want to do that. So that's one of the things that we have to control for, is not use too much power too quickly from the battery, or else this will automatically turn our robot off. Yeah, so this is what the real power distribution panel looks like. Each port on the channel, or each port on the panel has a red and black. So each one of these is one output. So you have a red, black, red, black. There are 16 total on here. In these little slots on the inside, they have their own little breaker, which allows it to protect against getting too much power drawn to like that single motor or that single whatever device is on here. So you do have to worry about opening up one of those and basically stopping the power from flowing to a single motor or something if you try to get too much power to it too fast. So we do have we have some limitations that keep everything safe. They stop anything from starting fires, smoking, any of that. So we do have to design around that a little bit, but it's normally not something we worry about too much. It's pretty easy to be safe with the way this is all set up. And we'll talk about the CAN bus item a little bit later. Okay. The logic side, which is basically what actually does the controlling instead of just like delivering power to everything, starts with the Roborio. This is the main robot computer. So this is what actually does all the controlling of the robot outputs and things. Without this, nothing would turn on, nothing would move. You could power everything up, some lights would flash, but you wouldn't actually have anything moving if you didn't have a Roborio. This is what we program. So this is how we will, when we start doing actual robot code, we will download the program to this, and this is what runs our program. This also sends all of the communication to the different parts of the robot, the different motors, all of that. And it communicates with the driver station using the radio. So the radio is just a Wi-Fi router that we use to connect to the robot very easily. So it's nothing that special. It's literally like an access point that you might have in a school building or something. It's just a tiny little Wi-Fi access point. Here's the Roborio, what it looks like, not in the graphic form. It gets its power up here, these terminals, from the PDP. So you do have to like power it up. If you just connect all the control stuff to it, it won't actually turn on. We'll talk about what CAN is in a little bit, but this is basically the start of the CAN bus. And we'll go through what that means here shortly. It connects to the radio with a normal Ethernet cable, like you might use from like your desktop computer to your home router, anything like that. So it's just a normal Ethernet cable, connects over to that. And then you can also connect to it directly. So there are times when we can't connect wirelessly. So when we're at events, if there's, there might be 30 teams, there might be 400 teams, all basically in like the same room. We can't all be connecting to our robots over Wi-Fi. It would start lagging. Things wouldn't work very well. So you're only allowed to use the wireless at events when you're actually competing on the field. If you need to do anything else, you have to tether to the robot. So we can either tether using a network cable, so we can plug in an Ethernet cable from our laptop to the Roborio or to the radio. But we can also tether with a USB cable, so you can plug it in just like you'd plug in a printer. And then that way the laptop will be able to talk to the Roborio, and you can control everything directly over the wired connection instead of having to use wireless. Okay. Yeah, this is what the radio looks like. This is a real picture, not just the graphic. It does allow other devices to connect to it, so we sometimes have other network devices, computers. One of the most common ones is a thing called the Limelight sensor, which is our kind of camera vision sensor, and it plugs in directly to the radio so that we don't have to go, and then it'll talk to the Roborio through the Ethernet and through the network. Okay, so this is the part that the top part is all the same, so that's the basic control system. What we added in this graphic are a way to actually control motors. So we have these two examples down here called motor controllers. And so every motor on our robot has to have a motor controller. If it didn't, and you just plug the motor directly into the power distribution panel, when you turned on the robot, the motor would just spin full speed in one direction and would never stop until you turn the main breaker back off. That would definitely not be safe, right? We definitely don't want to like hit a single button and have the robot drive away and sprint away and just keep trying to run through whatever's in front of it, right? It would try to run it through walls, tables, whatever's in front of it, and there'd only be one way to turn it off, which is to get to that red button. So we would never connect it directly to the PDP, as that wouldn't be safe at all. We wouldn't be able to set up the robot. We wouldn't be able to work around it. You just wouldn't be able to control that motor, and we always want to be in control so that we can be safe. So these motor controllers allow us to do that because basically they will connect to the PDP, so they will have power, and then they will be in between the PDP and the motor, so that when the Roborio can tell it to go forward or go backwards or go to a different speed, the motor controller can do that. And when our controllers, when we disable the robot, the motor controllers know to stop the output to the motor so that everything is safe and we don't have to worry about the motors not doing what we expect them to. In this example configuration, we have, we have PWM wires. For now, don't worry about what PWM stands for. It is an acronym, but you don't need to know what it is. Just know that it's called PWM. And this is basically the older way to control motor controllers. So the Roborio can still do it. It basically will send signals to one of 10 ports. So you could have 10 motor controllers connected here. And then each one has a wire going to the motor controller. And so you could tell the motor controller at port 0 to go full speed forward, and you could tell the motor controller at port 1 to go full speed backwards, and they would do that. You could tell them to stop. You could tell them to do whatever you wanted. But you have to basically make a wire that goes from each motor controller back to the Roborio. And that's basically all you can tell it to do too. You can't tell it, you can't like actually talk to it at all. You can really just give it a command and basically tell it, okay, go full forward, go half forward, go quarter forward, whatever you want to do in that range from full forward to full reverse. But that's all the information you can send to it. Yeah, the PWM is very similar to what a RC car does. So if you've driven an RC car and you tell it to go forward or backwards, a lot of times they have PWM control. So that's all they're doing is getting some amount of full forward, full backwards. That's it. The other way that you can connect motor controllers, which are often which can be the same motor controller. So almost all of our motor controllers can do both of these setups now. They can do CAN or PWM. Any of the latest ones, any of the ones we would buy now, can do both. We still have some old ones that can only do PWM, but we would never put them on any of our modern robots anymore. So CAN is the other option for being able to control motor controllers. So the CAN bus wires are a smart way to control motors, basically. So instead of just being able to tell it to go forward or backwards, we can now, the motor controller can know things about the motor. You can have sensors plugged directly into it. It can know like how much power the motor is getting. So then you can start telling it, you can do much more advanced things like telling the motor, okay, only drive, spin 4 times, spin 4 revolutions instead of only going like full forward, right? You could tell it to spin to a certain RPM, certain revolutions per minute, so a certain speed. Um, so you can do a lot more with the smart motor controllers than you can with just the PWM ones. The other nice thing is they get what's called daisy chained. So instead of having to have one wire for each motor controller going back to the Roborio, we just have to send um, one wire, one yellow and green wire each to the first motor controller, and then that motor controller connects to the next one, and that one to the next one, and so on. So it makes the wiring a lot easier because we just don't have to have everything run back to wherever the Roborio is. Um, Motor controllers. So there are a bunch of different types of motor controllers. Um, the pictures over on the right are 2 of the most common. Um, so Spark Maxes are one of the motor controllers. Talon SRX is another one. Um, Victor SPX is the last like modern one that we would be using. These 3 are basically the ones that would be on a robot most of the time. There is one special example that we'll talk about that you'll know kind of more about what it means, but for some people who may not, the Falcon motors, which were brand new last season, have a motor controller, but they're built in. So it almost looks like we're doing things incorrectly because when we just said we don't want to connect a motor directly to the PDP, but for the Falcon, basically these 2 things are combined into one. So we do plug the wires directly in, but the back of it has the motor controller already attached. So it can do all of the smart features, it can do everything we need it to, and we just don't, it can eliminate some of the cabling between everything. Um, Motor controllers are sometimes called speed controllers. So if you hear somebody say, what speed controller are you using or whatever, motor controller, speed controller, basically interchangeable. They can use PWM or CAN. We'll almost always just use CAN on our competition robots. There's just no reason. Like CAN has so many benefits, and there's really very few negatives compared to PWM. So we'll almost always use CAN. PWM is simpler sometimes, so teams may choose to use it. We've already gone through most of this, but yeah. So the CAN allows the Roborio to actually talk to the motor controller and get information back and send information to it. There's a lot more advanced features. There's a lot more advanced features with CAN. With being able to control the motor in much more interesting and way more controlled ways when you have a CAN motor controller compared to a PWM one. We talked about driver stations earlier, but we want to make sure you actually saw what ours looks like. So this is our driver station that we've had for about 1.5 years, I think. No, actually like 2 years now, probably. So this lets us have our laptop here. We have a second monitor that plugs into the laptop. And then we have 2 Xbox controllers. So the Xbox controllers, one of them is for the driver and the other is for the operator. So you have 2 people controlling the robot at the same time. The driver is responsible for driving the base. They may have some other commands that they do. And then the operator is responsible for most of like the scoring actions and anything with the game pieces. So they'll often be the ones picking up the balls or whatever the game piece is. They'll also be like in charge of making sure the launcher is working. Any of those things, and there's sometimes a gray area, and different tasks will be on each person. But that's mostly how it gets broken down. The second monitor up here is actually for we use it for the camera stream, so we'll have a view from the robot on this second monitor. So myself as the drive coach or whoever's drive coach in that match, and the driver and operator can all see the robot's view, plus look out over the screen and look at the whole field as well. Most of the time we're driving by actually looking at the robot through the plastic driver station window. But sometimes maybe the robot's around a corner so we can't see it, or we need to like make sure it's actually like aimed in a certain spot, so we need to be looking at it through the robot's view. So then we'll look at the camera for that. Okay, here's what the controls actually look like on a robot. So it's a little tricky to, let's see if we can. Oh, why doesn't it want to zoom? Um, okay, well, that's where we're at. It's okay. We'll just do it from this picture. So yeah, so we have the Roborio here. This little cutout where this purple strap is where the battery would be. The battery's not in the robot right now. The battery would just sit in here and get connected to that red plug. Um, the main breaker for our robot is off to this side, so it's like the back of it. So we'd be able to turn it on and off from the outside. You don't want to have to like reach your hand too far into the robot to have to turn it on and off if you can avoid it. Um, there's some more. There's like the radio up here behind here. There's some more wiring that you can kind of see, but it definitely looks more complicated on a real robot because things aren't just like laid out in a nice flat pattern everywhere. We have a lot of things mounted on these like walls. Um, the different motors are in different places, so sometimes their motor controllers are next to them. So it gets a little bit more complicated once everything's on the robot. Um, but all of it is really just like we saw at the beginning. Um, okay. Um, yeah, so the basics is what you basically need to know now. So with that, we can kind of start thinking about how we actually use this and program this when we're going to make the robot do things. Um, so next up in 1.3, we're going to talk about what the programming for the robot can actually do.